Okay, we've still got a couple more people trickling in, but I'm not too worried. Let's get started looking through our agenda. We have a warm-up in the chat. Would you rather be a technological or an engineer and designer? I'm not sure if everyone knows the difference. We went over this a fair amount in the last semester in my class, but the difference between a technological, hang on, the difference between a technological designer and an engineering designer is very stark. The technological designer is purely interested in providing a great product for humans. They are not concerned about how they are going to make it. They are not concerned that no product exists that has these properties yet. That is the domain of the engineering designer. The engineering designer has to create what the technological designer has imagined. So engineering designers are very grounded in reality. They are about how are we going to make this? What materials are we going to make it from? What tolerances do we need? You know, things like, does it need scratch-proof glass? We're dying to have listened in on that meeting at Apple, because it is pretty amazing. Hang on. But there had to have been a meeting where somebody said, gee, what if we made the glass on our phone out of diamond, and that way it could never be scratched by your keys in your pocket? I bet that went over like a lead balloon, but that's what they ended up doing. Look, we have Alex Garcia wants to be an engineering designer. Neo thinks that technological designer is more for him. They are two very different people and personality types. I would be a technological designer because I can imagine things and I can imagine how this is going to work and fulfill a need. But doing the nitty-gritty technical work of figuring out exactly what is going to work, how many amps the fuse should be, is it better to have 5% titanium or 3%? All those considerations are in the camp of the engineering design. Okay. So look, oh, we've got loads of engineering designers, people who like things in an orderly world. Part of the fun of being the engineering designer is you have control. You are doing this all yourself. It's your research. It's your project. And it was very interesting reading some of the comments last time. Look at how many engineers we have. I'm so excited. I did a project for PBS NewsHour when I was the head of their STEM and health student reporting labs. And I think I've already told you this story. Oh, Natanya, you've already been here. Shoot, now I've forgotten my track. Oh, it's the idea that when you guys are looking at stories, you need to find the point of interest. So I was doing STEM work, right? I was helping kids tell stories with a STEM or health angle to them. STEM is science, technology, engineering, and math. And we'll see a lot about this in our coming up project. The one piece of that I felt people didn't understand was engineering. That you know what science is, you know what technology is, you know what math is. What is an engineer? What exactly do they do? What do they look like? I'm stuck in the 50s. My picture of an engineer is a guy with big black horn-rimmed glasses, a pocket protector, and a slide rule. But I met a gentleman who is the head of Johns Hopkins Applied Physics Lab. He's the head of their AI department. He told me engineering is all about imagination. I said, well, Lawrence, somehow nobody ever told me that before. He goes, no, really. It's all about imagination. Because today, sort of like in feature films, almost anything you can imagine, you can create now. It is such an open palette. And engineers are the ones who make it work, who get it done. I have another story of my brother who was a math major at MIT. He said it was easy to be a math major at MIT. I said, really, Matt? Don't see how anyway being a math major is easy. And he said, well, at my level, he was in Calc 5 at the time, it's all theoretical. So as long as the equations balance, I have the right answer. But the engineers have to do their calculations based on theory, but then have them work in practice. They have to build what they design. And the problem is theory and practice do not always match. What should work and what does work are not necessarily the same thing. So the engineers have it twice as hard because they have to do the calculations and then they have to create it in reality. All right? So I am incredibly proud to have a class so full of engineers, and I'll be a technological designer. And let me see, I think we only have one other technical, my friend Isaac and Dixon. Oh, look, there are a bunch, they're nailed. We will be the technological designers giving you guys what you need to build. All right, it is a team effort. Our agenda looks a little full. That's because we use a lot of big words in this class. What the plan is we are going to finish our presentation on information and communication technology. A lot of people have already turned this in and they are making a mistake. They keep saying that the word is information technology and communication technology, but they keep defining it as information and communication. That's because we didn't have a very good definition yet. So you'll see there is a better definition today, but you can look this up on Webster's. Just put in information technology, communication technology. One of the confusing things is it will say information and communication technology do this. And that seems to be the way it is. Again, information technology is the idea of sending things through a network, but it's sending information through a network. Communications ideally are more geared to people, but information and communication technology seem to have very similar definitions in terms of providing means of disseminating information through, typically print medium, telephones, television, those kinds of things. All right. We will finish our presentation on engineering design process. And the reason I want to get through that is I have a new project to introduce you to. Black History Meets Technology. So I've been reading a few accounts at the start of class of interesting historical or significant Black technologies. What we are going to do now is we are going to create a whole project based on you figuring out one Black innovator or technologist that you would like to profile and doing a short series of slides to make a biography of them and help everyone understand what they did. All right, we will go over that. We'll hopefully have about 15 minutes at the end. What is due? The Information and Communication Technology vocab quiz. It's due tomorrow, I believe. So Black History Meets Technology worksheet. That is going to be a worksheet that just has the 3 characters that you have narrowed down, that these are your final 3 that you're going to make a decision from. And then who did you decide to go with? Why did you decide to go with them? I want you to pick someone whose story resonates with you, whose story either is just something that you love or something that speaks to you in your experience, okay? So that's what we'll be doing. You will learn more, don't worry. The final project, Black History Meets Technology project, will be due on the 23rd of February. So we will have 2 weeks from today to get this done. By then, with any luck, you'll all have your supplies and we will start working on our next more hands-on project. All right? Our objective or goal is that you will be breaking down the differences between information and communication technology. They are different, but they are also very similar. They deal with very similar things. Transmission of information, okay? We'll also be applying the engineering design process to our Black History project. Ooh, how are we gonna do that? Engineering, literature, can they go together? I don't know. Stay tuned to find out. All right, let's get into it. I can't tell you how excited I am to have a class of engineers. Here's where we left off. Communication can meet one or more of 3 basic goals, okay? So this is like the core technologies for creating a technology or technological system. You need a piece of one of those 9 if you are going to be creating technology. In communication, they are saying there are 3 basic modes of communication, right? What could they be? We're not pausing, we're firing right ahead. Communication can meet one or more of 3 basic goals: to inform by providing information about people, events, or relationships. We read books, magazines, and newspapers to obtain information. Radio news programs, television news programs, and documentaries are designed to provide information. So those are information technologies, all right? Radio, television, news programs, documentaries, okay? The second mode of communicating is to persuade people to act in a certain way. Examples include the Say No to Drugs campaign, Buckle Up, Give a Hoot, Don't Pollute campaigns. These are persuasion campaigns. They are trying to convince you to do something, to say no to drugs, to buckle your seatbelt, to not pollute, to put out your campfire so you don't start a forest fire. Okay? Okay, bonus question in the chat. Anybody know who said, give a hoot, don't pollute? Anybody? I was hoping you guys knew. It's like Woodsy Owl, I believe is his name. The campaign was give a hoot, don't pollute. Okay, print and electronic advertisements, billboards, and signs are typical persuasive communication media. The third aspect of communication is entertainment, to entertain people as they participate in or observe events and performances. Don't do this in the movies. No communicating about the performance in the movie theater. Everyone gets sad when someone's explaining things in the seat behind them. Television programs, movies, and novels are common entertainment type communication. The 3 goals may be merged. 2 new words in our language arise from this merging of goals. The first is infotainment, which means providing information in an entertaining way. You may learn as you watch a quiz show on television or play with video games and computer simulations. Both of these are enjoyable ways of gaining new and useful information. I used to work in infotainment. I work in television for many years, and I didn't like working in commercial television. I worked more in documentary television. So we were always trying to find ways to entertain our audience while providing real valuable information. Okay, so like I did a story about America's big cat crisis. The idea that in many states there are no laws against private ownership of exotic animals. That in the state of Texas, there are over 5,000 domestically owned tigers. There are only 3,500 wild tigers in the wild in the world, but there are 5,000 in Texas. That's because back in the 70s, zoos figured out that if they had babies, people came to the zoo. And then they didn't know what to do with all their babies, and they ended up getting rid of them in a way that was not really appropriate. That they did not neuter the animals, they allowed a third-party dealer to sell them, in theory, to a reputable organization, but they just sold them to the public. So that is where a lot of the breeding stock of lions and tigers come from. The problem is they are considered generic because they don't have a pedigree, and nobody wants to release a generic tiger into the wild. So it's a misconception that you can save tigers by raising them domestically. Okay, back to infotainment, providing information in an entertaining way. The idea was that old school PBS, long form natural history, was boring people, that there wasn't enough action in it, wasn't enough contact with people to make you interested and watch. So that's why we started to develop stories that were more exciting, but also had the core information that you needed. So you may learn, all right, I think we've already done all that. The second term, edutainment, takes communication one step beyond infotainment. Edutainment is more than allowing the information to be available in an entertaining way. It creates a situation in which people want to gain the information. The television program Sesame Street is a good example of edutainment, that it educated young kids enough to want more education. So the line between infotainment and edutainment seems a little blurry, but it's the idea that you are creating a product that not only entertains, it educates. Data and information are of little use, however, unless they are shared. This is what communication does. It involves a message someone wants. It involves a message someone wants someone else or something to receive. When we use technical equipment in communication, it is called communication technology. So there's a definition of communication technology: the use of technical equipment in communicating. The use of technical equipment in communicating is communication technology. That's a very simple definition. Okay? Technological knowledge and processes are communicated using symbols, measurements, conventions, icons, graphic images, languages that incorporate a variety of visual, auditory, and tactical stimuli. Okay, we're talking about communication. For example, the international symbols developed for transportation systems have helped to communicate critical information to travelers. A circle with a slash represents no or do not do. My favorite is the no bozo, not the Ghostbuster. These are very sort of European. I think that's where I first saw them. But let's look at some of these other symbols: the men's room, the ladies' room, handicap, the airport. Toxic, I like very toxic. I've never seen that before. Highly inflammable, or highly flammable, and extremely flammable. And where is inflammable in here? Danged if it's not the same thing. Always confusing. So these are all international symbols. The beauty of symbols and things like emojis is you don't necessarily need to speak the language in order to understand what the symbol is showing. Okay, now it's true. Oh, look, there's a little eye down here. I was saying the difference between the harmful symbol and the irritant does seem to be difficult to see. All right, emerging technologies often generate new symbols, measurement systems, and terminology. For example, the semicolon dash right parentheses is a symbol used in email and online chat rooms to represent a wink. See, they're winking at you. Communication technology uses equipment and systems to send and receive information. Okay, so right here, if you do not have a good definition in your vocab, please go back in and change it. Put the right definition in. Information technology is not information, it's information technology. There is equipment and systems in there, but communication technology and information technology are incredibly similar. So I will say right here, we can almost use this definition for both. Communication technology uses equipment and systems to send and receive information. If I put information technology in there, it would be the exact same thing. Information technology uses equipment and systems to send and receive information. Okay, so they are very closely tied together, but it is that intrinsic difference that information is just information. It is data. Ideally, it has been sorted, but it needs you to utilize it. Where communication is two-way, is from something to something. Communication is always directed at someone. You are never just screaming at the air. You are always communicating with someone. In broadcast news, when he sticks his head out the window and yells, "I'm mad as hell and I'm not gonna take it anymore," he's not yelling to no one. He is yelling at the world and expecting the world to listen. Okay, so that's a great thing. All right, communication technology is used for 4 distinct types of communication: human to human communication, human to machine communication, machine to human communication, machine to machine communication. Human to human communication is people communicating with people. You've seen that before. This type of communication is the most common. It works through our electronic media and printed products. People are talking to other people. People are sending messages to other people. This type of communication is the easiest to use. 2, human to machine communication. People telling a device what to do. Keyed material into a computer. Set the temperature on a thermostat. Dialing a phone. Changing a TV channel. Sending a text. This type of communication system starts, changes, or ends a machine's operations. Okay? This is humans telling a machine what to do and it doing it. You are communicating. 3, machine to human communication. Oh, I meant to fix this, but I didn't. Devices telling humans what to do. It's not devices to devices. That's the next one. Reacting to a traffic light is a machine telling a human something. Reading a warning light on your dashboard of your car. Railroad crossing signal. Large things coming down, clanging sounds, red lights flashing. That is communicating. Danger, warning, danger, Will Robinson. A bell that indicates the end of the class period, everyone's favorite form of communication, or firearm. This type of communication system is widely used to display machine operating conditions. Okay? Machine to machine communication, devices telling other devices what to do. Computer controlled operations, computer to printer, cell phone to cell phone, smart car to smart car. Human enters programs and data into the computer, and then the computer directs and controls a device. For my last semester, think about the closed loop system of a water sprinkler. There is a sensor seeing if the lawn is dry or wet. So when the sensor says that it is dry, it tells the system to turn on and shoot some water out. As it feels that it is wet, it tells the system to stop allowing water in, that we're all done. It monitors the output to regulate the input, okay? Examples of this type communication include a computer controlling a printer, a thermostat controlling a heating or cooling system. Typical examples of computer-controlled operations are computer-aided design, or CAD. I think we've all heard of that. Computer-aided manufacturing, CAM. I have not heard of that. I'm guessing this is the idea of use of robotics, or computer-integrated manufacturing, SIM or KIM, and then robotics, all right? So I think integrated is a more robust computer integration than just aided. Much of communication technology was developed to satisfy the need for mass communication. People wanted to tell their message to large numbers of other people through printed media. One type of communication system is playing an interesting role in our modern life, and that system is telecommunication. Communication at a distance. I'm sorry, my skylights get me right about now. The internet allows people to gather information using the World Wide Web and exchange messages using electronic mail, okay, and a bunch of other ways. Communication and information technologies are a part of every person's life. We use graphic and electronic communication media daily. This media allows us to send and receive information. Information technology allows us to access and use vast quantities of data. Communication and information technologies inform us or cause us to take action. Without communication and information technologies, we would know little about the world around us. We would only know what people told us. It used to be incredibly important when somebody from out of town came to town because they had news of the world. Our lives are affected daily through these systems: communication technologies and information technologies. All right, we're into the summaries. We're gonna make it. All right. We are rapidly moving from the industrial age into the information age. This new age is characterized by the wide-scale availability of communication media. People receive and send a constant barrage of data and information every day. Each communication message is designed to inform, persuade, entertain, or achieve some combination of these goals. So that's what I mean by it's very similar to the 9 core technologies. Any communication message is designed to either inform, persuade, entertain, or achieve some combination of those goals. Transfer of communication is done in terms of human to human, human to machine, machine to human, and machine to machine. Each of those systems has a transmitter that decodes and sends the message. You wouldn't decode to send a message. The message then travels to encode and send the message. The message then travels over a carrier to a receiver. The receiver then collects and decodes the message. The most common forms of communication systems are printed graphic, protographic, telecommunication, technical graphics, and electronic computer and internet communications. Communication technology uses technical means, equipment, and systems to exchange ideas, information, and opinions. Information technology is data. See, that's just wrong. And this is the answer that people have been giving me. Information technology is not data that has been sorted and arranged. That is information. Information technology requires equipment and a system. It is technology, not just the information. Knowledge is information that humans can apply to situations. Interference is anything that impairs the accurate communication of a message. Human-to-human communication is one person directly providing data or information or ideas to another person. I think we know machine-to-human. Machine-to-human is me programming my VCR. Oh, machine-to-human is actually my car telling me to put on my seatbelt. Human-to-machine is me programming my VCR. How did we lose Ashley? I swear she was here. Right. Machine to machine is your computer telling the printer to print, your smartphone calling another smartphone. Printed graphic communication is exchanging information and ideas using two-dimensional images reproduced on a substrate. Printing is the process of producing copies of a text and images on a substrate. Photographic communication is using photographic images to communicate information or ideas. Telecommunication is communication at a distance through electronic means. Internet, interconnected network of networks, is a network of computers that enables people to send and receive messages and share information. See, again, I apologize. I really need to groom these before I go through. The World Wide Web is not an interconnected system of computer files linked to one another on the internet. The internet does not consist of a series of files. The internet has a lot of files in it, but the internet is really run by a bunch of servers, okay? So that is, and it's your independent service provider, your Comcast, your Verizon, et cetera, that make the World Wide Web run consistently. Phew, all right, we made it through that. I apologize that today is a lot of information and it's a lot of me droning on. I want to get through this information because we're going to be able to use these ideas and tools in our project. And I want us to get to our project. Okay, so here is where we left off last time. And this is our engineering design process. You're all wondering, how are we going to use our engineering design process in a paper? All right, well, let's just start back where we were with scientific method and engineering design process. Scientific method has an exact starting point, a hypothesis, it's closed-ended, defined linear procedure. Engineering design process is human needs and wants oriented. There's a culture of continuous improvement. That is called iterative generations, that you are doing a process in an iterative process, creating a better and better product every loop. Design is a part of engineering design process and identifying constraints. What can't we do on this project? That really helps to inform what you can do. All right, there are a variety of formal and informal problem-solving strategies and models beyond the scientific method and engineering design process. The process of engineering design takes into account a number of factors. Don't know why I'm getting yawny. Science is the study of the history of the natural world and how the natural world works based on observable physical evidence, okay? Science is the study of the history of the natural world and how the natural world works based on observable physical evidence. The scientific method, processes of discovery and demonstration, observation of phenomena, formulation of a hypothesis, experimentation, conclusions. The steps of the scientific method: you name the problem or question, you form a hypothesis and make a prediction, whether it will be true or not. Test your hypothesis, interpret your results and hypothesis, report your results. That is what the steps of the scientific method are. Engineering design is systematic application of mathematical, scientific, and technical principles, tangible end products that meet our needs and desires. The process of engineering design takes into account a number of factors. The engineering design process is a systematic, iterative, it goes in loops, it's repeated, problem-solving strategy with criteria and constraints used to develop many possible solutions to a problem to satisfy human needs and wants. Okay, here is the big engineering design process. Okay, this is 12 steps. For our literature process, you'll see we are going to use a modified version of this. All right, so the first step is define a problem. 2, brainstorm possible solutions. 3, generate ideas. 4, research ideas and explore possibilities. 5, specify criteria. Identify constraints. 6, consider alternative solutions. 7, select an approach. 8, develop a written design proposal. 9, make or model a prototype. Test and evaluate. 11, refine, create. 12, communicate results. All right, that's a lot of steps, but each one is critical to the next one. Here is the loop that we will probably be using for our design process. What else do you need to know? That design is a process and also a tool. That there is a process. There are a number of steps that you go through when you design something. A creative tool that is used in a technological design and is the backbone of technological literacy. The design process is a creative tool that is used in a technological design and is the backbone of technological literacy. So we start with 1, we state the problem. 2, we generate ideas. 3, we select a solution. 4, we build the solution. 5, we evaluate our solution. 6, we present the final solution. We present our results. Okay, designers clearly outlines what human need or want exists to solve the problem. Often design problems are not clearly defined. Designers may have to investigate to define the problem. For example, a company might call you in and ask you to solve the problem of the company losing money. I swear I had it yesterday. Determine why the company is losing money. What problem needs fixing? Designers generate ideas without consideration or limits to the design. Brainstorming is a group of individual problem-solving design process in which each person in the group represents his or her ideas in an open forum. Wow, that's great. Okay, so brainstorming is a group or individual activity problem-solving design process in which each person of the group represents his or her ideas in an open forum. This is a step where a designer can let their imagination run free with suggestions from the brainstorming session. Research to determine if a solution to the problem already exists. Maybe someone's already done a biography on the person you've chosen. All you have to do is find it and then cite that work in your citations, and you can use what they're telling you. Can another solution or product be adapted to solve the problem? Is there something else we could do here? Okay, this is a classic example. This goes to our COVID vaccine. The problem was making a regular vaccine would take too long. That is why the Pfizer and Moderna, I believe, are based on RNA, not DNA. RNA is recombinant nucleic acid, and it is half of a strand of DNA. It is the template for the DNA. So our vaccines no one has ever created an RNA vaccine before. And that was because there was a problem, and the only way they could get past it was to try and make one out of RNA. It was just going to take too long to have to do it the old-fashioned way. Is there mathematical or scientific information related to the problem that needs to be collected through research? Designers begin to explore the possibilities generated during the brainstorming session and the research gathered. Identify criteria and constraints while providing the basis for what the design should be and what its limits are. Criteria identifies the desired elements and features. Constraints involve the limitations. So remember that. Criteria identify the desired elements and features. Constraints involve the limitations. The possibilities are measured up against the defined criteria and constraints. Other solutions could work just as well as the ones selected by the designer. Remember, like coding an app, there's probably 5 different ways to do it. You don't follow just one path. There are multiple paths. I don't think we've had a cat. Nope. All right. Other solutions might be simpler or less expensive and therefore more desirable. There is what is called an elegant solution in the world of chemistry, physics, etc. It is the simplest solution. It is the solution that takes the least effort to explain all phenomena seen occurring in this situation. So clean, easy to read code is more desirable than very complex, convoluted code that is buggy. Okay? Based on the analysis, the designer chooses the solutions that best meet the criteria and constraints. The selection of an approach is closely documented. In the event that solution does not work, the designer may need to repeat steps. Okay, develop a written proposal. A design proposal is a written plan that specifies what the design work will look like and what resources are needed to develop it. It can be communicated through sketches, drawings, models, and written instructions. Okay, make a prototype or model. Models allow a designer to make a smaller version to save time and money. So you can see a mock-up. Physical, mathematical, or graphic models are used. A prototype performs exactly as the final solution and is used for testing. A mock-up physically looks like the final solution, but does not perform as the final solution. All right, I swear we're almost done. Models and/or prototypes design meet established criteria and create the design. Based on the evaluation and testing results, designers refine the design of the product. Refinement and optimization include function, making it work better, economic, making it more affordable, giving it more market appeal, ethical, making it safer. The product is then mass produced to be sold on the target market. Designers and engineers work together to design a cost-effective and time-efficient process for producing the product. Designers need to communicate their results to perpetuate innovation so others with similar problems can learn from their design process. Communication of the design process can include design portfolios, journals, drawings, sketches, and schematics. This is also part of the patent process. When you patent something, you are required to disseminate designs and drawings, schematics, and things. The patent office wants you to be sharing your idea with the rest of the world. One, because it stimulates new innovations. But two, that is why you have the patent. The patent allows you to keep control of your product while sharing it with the rest of the world. Okay, that is it. Woohoo! Okay, I am stopping sharing for a moment. And let's get into, I want to introduce you to our big project. All right. So here we go. We've got 15 minutes to go over this, and we're going to look at a little video on APA citations. All right. African American History Month meets technology. I would have put foundations of technology, but it was just way too long. This project is going to be worth 30 points, 30 assessment points. Our objective is identify a famous African American, Afro-Latino, basically any person of color that is an inventor or an innovator and you admire them. They need to be in the field of engineering, science or medicine or technology. And you are going to be creating a biographical slideshow about them and their accomplishments, right? So I have already been reading at the start of class about one or two famous Black technologists. Now we are going to open up the world to all famous or historical Black technologists, and you guys are going to get to pick your favorite to do a story on, to create a little slideshow biography. So our instructions: use the engineering design process to help you develop your ideas for a story. Steps in the literate engineering design process. Who are the candidates? Develop resources for ideas for which inventor or innovator you would like to focus on. 2, refine your list by narrowing it to 3 people. Okay, that is the first part of the worksheet. The worksheet needs your 3, you've narrowed it down to 3 people. It needs who are those 3 people and what are their inventions or why are they famous. Okay, then do initial cursory, cursory is short. That's what cursory means. Cursory research on each candidate and decide which will have the best story or the story that resonates most with you. I want you to work on something that you find exciting or someone that you find interesting or that you would like to become or emulate. All right. We are going to submit a worksheet with our 3 candidates and our final pick. Which one of those 3 did we pick and why did we pick that person? It can be because it's my favorite name I've ever seen. It's your pick, but just try and explain why you chose that person. What is it that spoke to you? All right, that is going to be due in a week on 2/16. All right, that is your worksheet. That is going to be our status check halfway through our project that you are almost ready to start building your person's story. Research and develop your subject's full story as best you can. Create your slide presentation. Quality control. Evaluate and fix any issues in your presentation. Present your findings. If you have a great project, I think we might let you present it to the class. All right, so here are the steps for success. So that is what we have to do. This is how we are going to do it. You will develop a PowerPoint or Google slide presentation using the criteria below. First slide is your title page. Who is your project on? Then it needs your name, date, class name, FOT is fine, and period. So FOT, P8, and Mr. Swift. That's 5 points, just your title slide, right? There is a minimum of 5 additional slides. You can use more slides if you like. You can use as many as you want. Please not too many because I have to go through them. But those 5 slides, the bulk of your story, are going to be worth 20 points. Here is a suggested series of slides. As long as your slides are factual and informative about your inventor or innovator, the person you chose, I am fine with you choosing what you want to present on your slides. You do not need to follow my little script here, but this is a general idea of how to make a nice presentation. So first, you have a nice title slide. Then we are going to introduce the subject, ideally with a picture, and why they are considered famous. I want the date of birth and the date of death on that slide. They're usually under the image of the person. On the next slide, explain the innovation or the invention or innovation, ideally with a picture. Explain the innovation or innovations, ideally with a picture, that they are most famous for and why it was significant in their time. Any impacts on society and economy that resulted from their invention. Next slide, identify an issue or problem they had to overcome. Examples, racial discrimination, fierce competitors, predatory practices of early days. Thomas Edison was not a nice man. He would sue people to try and keep them from impinging on his patents. We read about Black Edison, who Thomas Edison tried to sue to take over. He was saying that he was infringing on one of his patents, but Mr. Woods won. So you need that there were a lot of pressures on early inventors and innovators. There still are. Okay, so just identify, was it racial discrimination, fierce competitors, predatory practices, Jim Crow laws, all kinds of things could be influencing their success. On the next slide is the patent number or license number, if you can find them. I know those are very difficult to get. Maybe who backed the inventor financially. Edison, I believe it was, why can't I think? J.P. Morgan. I believe J.P. Morgan was Edison's big backer. So were any laws influenced by their invention? You do not need to include all of these. These are just ideas for a 5th slide. 6th slide. So this is the last of our 5 mandatory slides. Anything else you have learned that people should know? Possibly, why does this character appeal to me? Or what is it that you admire about them? I would love to hear that on your last slide. What is it that you learned from this? Why was this person significant to you? What made you choose them? What did you learn by studying them? I would love to see that. The last slide, 5 points. Last slide is 5 points. Those are your citations of sources in APA or similar style. I have a video that I'm going to show you. Okay, the entire project is going to be due in 2 weeks. All right. I apologize. Today has been a lot of me reading a lot of stuff. I wanted to get through all that so that we can be more experiential and engage with our project in the next class. So we're going to be working on this tomorrow. All right. Right now, I'm going to watch a quick video on APA style. How do you create APA citations for your project? All right. These are typically considered the best way to be creating citations. We're just going to be looking at internet citations here because I think that is typically how you are going to be getting your material. It's not here. We are. Are we all seeing this full screen?
Yeah.
I'm not, are you seeing this?
Yes.
Okay.
Yeah, we can see.
Hi, I'm Matt. So you're writing your paper and you found a great website to use as a reference. But how are you supposed to cite in an APA if there are no specific guidelines? The information you need is similar to other website citations. The author's name, the date the website was published, the title of the web page and the website, and finally, the URL. Now you can build your citation. Start with the author's last name and first initial. Next, write the date the website was published inside parentheses, with a period after the closed parenthesis. Use the year, month, day format. Now put the title of the web page in italics, followed by the name of the website. The name of the website should not be in italics. And finally, include the URL. Do not include a period or any punctuation after the URL. As with all citations, use a hanging indent after the first line. There you have it. And remember, this is how you cite websites that aren't specifically given citation guidelines. Be sure to use EasyBib citation tools for.
All right, so something I will try and do is get I'm just gonna take an image grab of this so that we'll have in our module what a good citation looks like. I would say half of my students are good about giving citations, but most are not doing it in the official technique, okay? So this is the standard technique. It will be very difficult for you typically to find the author of the thing that you are looking at, much less the date of the website being built. I would be more interested in the author and the date of the article that you're working with here, if you could find that. A lot of times you can't. So it would just be the title of the article that you're looking at, and this is in italics. This is the title of the article. How long can a spinoff like Better Call Saul last? The title of the website, no italics, and then the link to whatever it was you were looking at. So relatively straightforward. Just, if you don't have any other information, give me the name of the name of the article we're looking at, the name of the website, and the link. That will probably be fine for full credit, okay? I know that we have students from 9th through 12th, so some of our citations may not be perfect. I'm not saying that they have to be APA citations. I'm asking that you do your best to give me good citations of the materials you've used in researching your paper. Just one last thing, let me show you in the module where resources are. We'll look at these tomorrow. Historical Black technologies. These are 17 historical Black technologies. This is an amazing list of about 50 inventions created by Black inventors or contributed to by Black inventors. This is a list of 50 most influential modern Black technologies. I think looking historically is wonderful fun. It's Black History Week, but what happened last week is part of history, isn't it? So I thought people might be interested in seeing modern technologies. The problem there is their profiles tend to be very positive. All right, we are done. Woohoo! Great day, really good. I am so sorry to be so word driven and not getting your feedback. We're gonna be doing more hands-on stuff soon. So just dream about who you'd be interested in talking about.
Thank you.
You bet, Barco. Bye, team. Desi, can I help you? Alex?
Yeah, goodbye, Mr. Swift.
Goodbye.
Wait, so the assignment is due in 2 weeks?
Desi?
The assignment is due in 2 weeks?
2 weeks, 23rd, I believe.
Okay, thank you.
I get confused with our weird weeks.
Bye, Mr. Swift. Have a great day.
Bye.
Are we gonna have other assignments like from this week other than that one?
For this week?
Yeah.
No, I don't think so.
Oh, okay.
You've got your vocab. We're going to start working on this paper tomorrow. I don't think it makes sense to start another section of, we're going to be doing 2 more technologies in the next presentation. So that usually takes, I present one day and then we give the assignment the next day.
Oh, okay.
So you should be fine.
Okay, and for the citation, like if you don't find any of this of like the information about like
Well, you're obviously
would you
going to
take
have the name of the website and you should have the URL, right?
yeah.
So those are the most important. If
You would not take off points if we don't put like if we don't find like the date and
No. That is really hard. And it's the internet. How many sites have you ever looked at that tell you when the site was made? Not me. I've never seen that date. So just, the basic things that I would like would be ideally the title of the article that you were looking at, what's the name of the website, and what's the link to the article. That's fine for full
Oh.
credit.
Oh, okay. And also I wasn't here last class.
Sure.
What did we do on last class?
So we did same things. We went through the first half of our presentation. And the good news is, here, I can put it right in the chat for you. We have a YouTube, it's in our announcements, I hate to say. We have a YouTube playlist that has all our lectures in it. So you can look at yesterday's class if you have a burning desire.
Oh, okay.
Hang on, I'm just going to give you this link in the chat. Not that one. This. Okay. It's to everyone. Okay. If you just click that link, it will take you to a YouTube playlist that literally has every one of our classes by date.
Oh yeah, I got it.
Okay.
Yeah.
So that should help you. Ideally, I do trim the start so that it should be starting at the start. But it's very much the same thing that we were reading through the information and communication technology, then trying to do some of the engineering design process. You really saw it all come together today.
Okay. Yeah.
So the only thing that you have for homework from yesterday for that is you need to do your vocab quiz for information technology and communication technology.
Okay.
Okay, and remember those words are right up in the top of the assignment, and the definition is just going to be information technology, basically, and communication technology are utilizing, systems and machines to disseminate information. There's a better definition than that, but that's basically what they are doing.
Okay.
Okay, and the communication is more people-oriented. Data information is more factual. It's there, it has its own use. It is not focused on people, where communication is always directed at something. Information can just be information.
Okay. Okay, thank you.
Can I help you?
Bye.
Bye. Thanks for asking. Thanks for staying.
Yeah, thank you.
You bet. Alex? Anybody home?